So I started, everybody say, Dr. Smith, remember to start the recording. Okay, so I'm now recording. Today is Wednesday, September 4th, 2019, and this is the second scheduled meeting of ITSE 2347 Advanced SQL Programming. Let's see, last week, I'm going to go kind of quickly to get started here. Last week we talked about creating variables. We can create variables, and we just have to remember the syntax. If you forget the syntax, easiest place to find it is Google. You can find a wealth of information in Google, find it very quickly. Then we talked about if-then-else logic. If-then-else logic in TSQL works just like if-then-else logic does any place else in the world. Yes. Oh, thank you. Yes, I would like to turn the projectors on. If-then-else logic works just like any place else, and nothing special about them. You do also have a case statement or a switch statement, the usual kind of stuff there. I believe I almost never use case or switch. And do we have our system? Are we coming up here? Yeah. I will usually build my case statements out of nested if-then-elses, just because I have more control over it. And programmers do tend to be control freaks. And if there we go. The system is coming up now. So I want to talk about looping. So the other thing, we have variables, we have if-then-else logic, and we have looping. Looping is very, very shallow in TSQL. It's almost all we really have is a while loop. While some condition is true, for example here, while I is less than 10, do something. So in this case, I'm just printing. In TSQL, we will almost never print except just to demonstrate that something is working or not. Very seldom does an SQL program ever do input or output. It just almost doesn't. It puts the stuff back into a database and signals what happened. But this is an example of the loop, while I is less than 10. So this is an example of a for loop. And if I executed that, it would execute 10 times because it's got the counter in it. So I have to do it all. I have to declare my counter, I, set the counter to whatever, 0 at first, while test it while it's less than 10, do something, and then at the end of the loop, increment it. So I don't have a for loop. I just have to build it. So I have a while loop, and that's it. And I very seldom ever use a while loop. Generally speaking, what I will use is, I'll say while something that's true. Now, I do not have the ability to say while true. So just don't even worry about that. It's not there. While 1 equals 1, while 0 equals 0, something like that. Then that's true. It's always going to execute. And then if my condition holds, my exit condition is true, break out of the loop. You has anybody had a teacher who said you should not break out of loops? Some teachers, some purists will say, don't break a loop. Okay, I am one of them. Don't break a loop unless you're only going to break one time out of a loop that is otherwise infinite. So while true, in other words, it's going to run forever, but there's one place to exit it. And that can be at the beginning, it can be at the end, it could be in the middle for all I care. But one place to come in, one place to enter the loop, which is usually at the top, and one place to exit the loop. If you have that, you have a well-designed loop. So there's nothing wrong with this loop saying if I is greater than or equal to 10, break. It accomplishes about the same thing. If I need a post-test loop, what is a post-test loop? The test comes at the end. So it's like, in C, you'd say it's a do while and a while do and a doobie doobie do. But that would be a while do, while, it's true, but at the end comes the place where you exit. So if I push it down to the end, it's a while do. If it's up at the top, it's a do while. I really only need one kind of loop. I can live with that. We're not going to be doing this a whole lot, but we do use it on occasion. Questions on looping. It works just like looping anyplace else. I can build any kind of loop I need out of that, and we'll have to. I believe that's it on that. Let me go to the next one. I think I have. Let's see, looping one. Okay. When we loop, what do we use a loop a lot for? What do we use a loop a lot for? Looping in reading a file is probably one of the most common ones. And you saw this when you were taking C or Java. You opened a file, mostly in C. You don't open many files in Java. It's difficult to open a file in Java, but you can. C is a lot easier. And what did we do? We had a loop that we called it the end of file loop. And we would read and we'd check for the end of file. And well, that's exactly what we're going to do here. Now that end of file loop is used when three conditions hold. That batch is called a batch processing loop. And I need these three conditions. I have an unknown number of records to process. I don't know how many, 0 or more. So it has to work on 0 records. In other words, an empty file, it has to give me correct output. It input ends with a known value, and that value is sometimes called EOF, or I have to have a way to tell when I hit it. Like when I walk up and bang, I break my nose into the wall, I know I've hit the end of my steps I can take. And finally, the last thing that when you hit that EOF, that last thing that you hit, that wall, is not counted as a step. Bang, I broke my nose, and that's I'm finished. Okay, this loop is commonly used to process files, but it can be used for many other things. Open the file. I read the first value. This is the important part. I read the first value outside of the loop. Do you remember that? Am I speaking a language that you know? Easiest thing in the world for me to do is just lose everybody. Do you know what I'm talking about? Sometimes this is called a priming read. Yes? Do you know what I'm talking about? I hear somebody talking. I didn't get that.
Yes, but a question, you said an empty file counts as a 0. So if you have a list of files and one in the middle has 0 content, but it's still named, it's still a file, that will break your loop?
Okay. It has to run this. Right now, I just have one input stream that I'm talking about. And if there are no data in the input stream, i.e. there are no records to process, my loop has to exit correctly and show that it's 0. It didn't process.
Sorry, I'm with you now. I was confusing a batch file with a list of actual files being entered.
Yeah. They call it a batch file because you collect all of your data, put them in a file someplace, and then you process through them. Okay. Yes? Do you know what I'm talking about?
I do.
Yes, okay. I'm checking the class now for, keep hearing. I guess that doesn't have anything to do with me. I'm hearing a strange noise coming from the walls, but I'll live with it. Okay, so we process while not end a file, process the record that you just read, then read the next record. So notice each time through this loop right here, after we open the file, we read the first record, check for end of file. We always check for end of file before the record's processed. Then read the next record, check for end of file, process that record. So no matter what happens, if I hit the end of file right at the beginning, I'm going to hit end of file right here. I'll not end of file, I'm done. Close the file. I didn't try to process something that doesn't exist. Now, I don't know whether that's 0 or what I call it, but I didn't try to process that non-existent file. Lots of times it's an error, for example, to cut a check to a non-existent person because they're isn't anybody in the file, and this would not do that. Sometimes called the sentinel loop. You'll see it used like this: read X, while X is not equal to 0, do something. In this case, I'm just going to add it up. Read the next X. 0 is the sentinel. When it hits 0, it stops. It does not process the 0. It doesn't add it in. It doesn't count it. It's not considered part of the loop. I also point that, I say this is like a, if you go to Kroger and you put that bar between the orders, okay? That bar goes and the checker reaches out, picks up an item. Is this the bar that says stop? If it is, stops, brings up your sale. If not, scans it, bags it, picks up the next item. You can't buy those things, those bars that say, please place this between orders. You can't buy that at Kroger. That cannot be something Kroger sells. How would you tell whether you wanted to buy it or not? You have to go to a special store that sells those. I don't know what they put between the orders there, but I guess a bag of carrots. It cannot be something that's in the file. Okay, let's go on with this. This loop can be written as something like this. I can say while true, loop forever, always loop. Read the first value. If that value is equal to the thing that's telling us to stop, stop, break out of the loop. If I get past that, I don't need an else. If I break out of the loop, I'm gone. Okay? And that is the same logic. Personally, I like that second logic. I like this logic better. It's a little more difficult to teach students to do. I don't know why. All of the books teach the one with the priming read, with the read outside the loop, and then so all of the books teach it that way. Very common loop, all the time. Okay, we're going to use one. Here is one of them. ADV set, use ADV DB, that's ours. Set no count on, because I don't want to see all that fluff and flutter go by about how many records were updated and all that. I don't want to see a lot of clutter on my screen. So I set no count on. That means don't count. Don't give me all of that counting nonsense. I declare some variables. Okay. And by the way, I'll give you this file. Update count, I'm going to count how many records I update. Set the update count to 0. I'm setting everything, what? First time 0. After that, I'm going to count how many records I update. Okay, here's where we start. I say I'm talking about cursors here. A cursor is another way to say a file. I'm going to take this SQL statement, this select something. So select some data from some file. Could be from a join, it could be from anything. Select from where? It's just a plain old select statement, and it has to give me the data that I want. That becomes my file. I'm going to treat that select statement as a file. It's a bunch of rows of records like this. Maybe it won't have any in it. Maybe it'll be empty. It still has to run correctly. Maybe it'll have 1 million. It still will run correctly. Go ahead.
It's going to be treated like table or like sequential file?
Right now, yeah, it's a table because it's the output of an SQL statement. What I'm doing, I'm taking this SQL statement right here, this select from where, this one that's inside of that, and I'm saying treat this as a file, but not yet. It's not open yet. You're going to have to open it like a file. It isn't open. It's just that's what it looks like. The data will be coming from this select statement, one row at a time into my loop. Okay. Now, I'll talk more about. Okay, now it's open on line 61. Open it. That executes the query. It's pulled into memory, And now it's ready to be processed one line at a time. The question is a cursor a type of a variable? Yes, it is, in the same way that a file is a type of a variable. And many times a file is referred to, the reading point of a file is referred to as a cursor. You'll hear that language about a file, where my next record that I will read from the file is the cursor of a file. So you'll hear files talked about in this same manner. Basically, I have pulled the data out of an SQL statement. They're in the memory of my machine, and they're ready to be processed. Why not? We haven't gotten to the end yet. Let me get through, let me get to the beginning first. Okay. Now, what am I going to do? I'm going to read. While I'm not in the file, process and read. I'm going to do that guy right. Okay, here is a read. Don't worry about what it looks like. It doesn't say read, does it? Well, it does, because I put that on the end as a comment. That's a read. Just take my word for it. It fetch. You do a fetch. Here, this predates most of the languages you have. So fetch the next value from the cursor, the name of the cursor, invoices cursor. Now I have to check to see, did I hit end of file? Did I get anything? Because remember how end of file works. If I'm walking towards the wall, I don't know I'm at the wall until I bang my head against the wall, if I'm a computer. So it has to actually hit that end. And so while fetch status is equal to 0, that means if fetch status comes back 0, yes, you have a good record. It worked. While the fetch status is 0, you have a good record. I know it seems a little backwards. You expect it to be 0 is usually false, but don't worry about it. It's just that's the way it works here. Think of it as end of file, a test for end of file. Did we hit the end of file? Did I get anything? Back up there. Okay, well, begin. Now here's my processing. Remember, I fetched that. I put these values. What did I fetch? I fetched the invoice ID and the invoice total. So the invoice total variable, if it is greater than 100, update invoices, set credit total gets credit total plus invoice total. Okay, now it says in the book, where I got this problem, the book is saying to give each of them a 10% credit total, but I don't want to do that because that's going to change my data. So I put a 0 in there instead of 0.1. It'll still show the same count at the end, but I won't change the data. So this lets me run it several times. Okay, I don't want to change anything. Where? And then increment the update count. Add 1 to the counter. I believe there are 3 of them in there in the invoices that qualify. Then what do I do? Read again. This is just simply a file read loop. It looks a little strange. There is nothing about this that you haven't seen before. This is just a plain old batch processing end of file loop. It looks a little weird. Don't everybody roll their eyes at me. It looks a little strange, but there's nothing about it that isn't, you're basically just doing this, and you've been doing that in programming ever since you wrote your first looping program. It was probably one of those. This is just one of them that's like it. And if I execute it, okay, I have to start up here and go all the way through. I can't execute a piece of that. When I get to the end, Execute. 3 rows are updated. I didn't change anything because I just added 0 to them, but that's okay. It hit 3 of them anyway. At the end, I have to close the cursor and deallocate the cursor, or I will get what's known as a memory leak, meaning I will leave memory allocated, that if I boot the computer, I think I get it back, or if I restart the server, but it starts using up memory. Okay, cursors are, what about cursors? I'm sorry, tell me your name. Chris, you told me about cursors. What about cursors? You told me last time. Cursors? Don't use them. That's what they say. Well, why am I telling you? Well, don't use them unless you have to use them. I mean, there's easier ways to do this. I could do this with an SQL statement. If I told you to get this done, you'd just write an SQL statement. In fact, there is an SQL statement right down at the bottom. But, I mean, I do it a different way here, but why not just do that? Update, invoices, set credit total, gets credit total plus invoice total times 0.1, where invoice total is greater than 1,000 and invoice total, is greater than 0. Less invoice total is greater than 1,000 and I don't know, whatever that is, why I did that, but where some condition holds. It'd be a whole lot easier just to do it with one SQL statement. In that case, just boom, and it all happens. Runs much, much faster. If you are gonna process through that thing using a cursor, you have to run the SQL. You have put it all in memory. You go through it one piece at a time, and you lose all of your optimization. It is very, very bad to use a cursor, except when the teacher tells you to use a cursor. And when you have to, if you just have to, and you're trying to find any way around using one of them. Okay, I ask you to use one of them to do something. I forget what it was in the first assignment. So you're going to open like that. You're going to go through these 3 steps. You're going to declare the SQL statement that creates the cursor, open the cursor, read the first line of the cursor, check for end of file, process it, read the next line of the cursor. When you finish, I forget what I'm telling you to print, but something, okay? It's just a plain old end of file loop. I think I do another one here. This is one I do exactly the same way. It's exactly the same at the beginning. I declare the cursor, open the cursor, there, open the cursor. Here it changes. Here I'm using the while true. Then I read. If it's end of file, if it's not equal to 0, break out. This is going to give me the else. Now, if I get past that, then I go through it and process it. Okay. This is a terrible way to process a database, but there are times when you cannot get out of it. So this is usually the first piece of advanced database. Don't do it. You now know how to do it. The reason you don't do it is because if you can do it as a single SQL statement, you are usually way, way ahead of the game. And I haven't seen very many times in my whole database programming career, which spanned a few decades, where I couldn't get around doing a cursor except when the professor wanted to show us what a cursor was. Okay, questions? It's not as difficult as I'm just trying to build on something that you already know. You already know how to do this. It's not something that's brand new. Close the cursor and then this, 3 records updated. Well, hey, do this and bing. 3 rows affected. I mean, it's the same thing, and I can write it a lot faster. So Chris is correct that you should not use a cursor if there is any way around it. It's not the first thing you reach for. Cursor. Okay. Try catch. This is a lots of you have done exception processing. Java has try catch. So what does try catch mean to you? I'm not trying to make you talk. What is, if you say try catch? Try to do something. If it works, fine, it works. But if it doesn't, you have an error block that handles it. They work a little bit differently in different programming languages. Some of them have nested. If you throw an error here, you come to different catch blocks. They can get pretty complicated. In TSQL, they're not particularly complicated. We have a block that says begin try. Begin try, end try. If any error happens inside of that begin try, end try, we end up down here in the catch block. Okay. For example, what if somebody had data? If object ID demo table is not null, before I'm going to use a table, before I create a table, I need to make sure it doesn't already exist. So what? I'm just going to drop it. Well, gee whiz, what if somebody had data in that table? What if it existed and somebody had data? Should I check that maybe first? So I'm going to check, I'm going to write my code such that it fails softly. If I just said drop the table and the table didn't exist, I would have an error. If I said, okay, create the table, and the table did exist, I would get a hard red error across my page. And I hate that. I don't like that error because that causes my code to error out. I don't like it when my code errors out. Part of this class is going to be keep my code from having errors. We hadn't worried about it up until now in 2309. Okay, if it has an error, we just have an error. It causes our batch to exit, and that might be a problem. Okay, basically we're going to try this. I'm going to try, begin try. I'm going to print a message entering the try block so I can see it happen. I'm going to try to create the demo table. I'm going to say create the demo table. Well, what can go wrong? Well, it might already exist. If it already exists, I'm going to exit this try block. I'm not going to get to line 15. I'm going to drop down into the catch block. In the catch block, I don't know what I'm going to do. I guess I need to go find out what's in that table. But the bottom line is my code does not error out, right? So if I say try, when I execute this, well, it apparently already exists because I tried to create it, but I ended up down in the catch block instead. Let's go ahead and drop it. If I drop it, now I'll try it again, try it with the catch block, and now it should create it, entering the try block, end of try block. In other words, I created the table, okay, using the try catch. If all I did was say create table, but it already exists, I'm going to get a big red error across, and all of my code just stops right there, comes to a screeching, crashing halt. And that's what I want to avoid allowing to happen in programming for a database. Don't let anything error out. Don't ever let your code hit a table constraint. Don't ever try to put a don't let anybody try to put a primary key that already exists into the database. But what he doesn't know what to put into the database. You got to stop him. And that's the code we're going to build. We're going to build our code that is idiot-proof. It's going to be very difficult to do because idiots are a very resourceful group of people. Questions? So this is the try catch block. Very simple in TSQL. Basically, try what's inside of the try block. If you get through it, good. We don't do the catch. If anything happens in there, then come out to the catch block. If no matter what happens, you never go backwards. You never go back into the try block. I always thought that you go back, but when I was learning this, and I kept expecting it to go, take care of it and then go back and finish it. Never does. Questions? I'm not going to spend a lot of time on the try catch. Okay. Dynamic SQL. We are going to be doing a lot of this, and I'm not ready to do an exercise on it yet, but I wanted to talk about it while we're here. You're going to get a lot of stuff from web pages. Your code, databases, and web servers run kind of hand in hand. The database, the love affair between databases and web servers is very, web servers are considered very promiscuous, right? They're not very careful about washing their hands and stuff like that, They tend to just go with anybody they find, and the database, on the other hand, has to be very protective. The database is, nobody cares about the web server, so what if they knock over the web server? All they're going to do is just mess up my web server and go in and put some bad words in there or something. Okay, I'll just fix it. But if they get into the database, that's very bad. So the stuff is coming through the web server into the database, and that's what we've got to protect against. Now, when it comes from the web server, what the field in the web server is your name. Okay, what is your name? You got a place to put your name. What is your quest? You got a place to put your quest. What is your favorite color? You got a place to put your favorite color. Gee, what happens with that? Well, somebody is chatting. Okay, let me check this. Oh yeah, blue. Wait, no, green. She says. That's a line from Monty Python and the Holy Grail. In case you aren't familiar with that line, it's a comedy skit from the 70s, sometime anyway. Okay, what happens is it gets built into a line of SQL. And let me show you how it's handled here. Dynamic SQL, so is a string of characters. And in that string of characters, it's a variable in my program. And that string of characters is built into an SQL statement, and then I say execute that. So it's like the SQL is giving itself commands. It's building the command. So it doesn't take the command from the web page. It takes the name from the web page and it puts that into an SQL string, and then from that it does the insert. For example, the username Bill, right, comes to us from the web page. Okay, I'm just going to say set username Bill. Okay, but this is coming from a web page. Pretend. We haven't gotten to the web page yet, but okay. So what happens there, I set my dynamic SQL gets insert into names. I need to create the names. Go ahead and create those now. Okay, insert into names, values, and then put the username right there with it. So I'm concatenating all those guys together. So I put the username into the SQL string, and then I say execute it. First I say print so we can take a look at it. and then I'm going to say execute it. So if I execute this thing, let's print it first. Insert into names, values, Bill. That's what I'm going to execute. No problem. I don't know whether I will see it all or not. Execute, and then select. There's Bill. Well, I guess the select wiped off the print, but Bill's there. Okay. Mary comes in from the web page. We execute it. Insert into names, values, Mary. Okay. Let's look. Yes, it's there. What's the catch here? There's something very bad going on. Although this is how you get stuff from a web page. What happens if somebody's name now let's see what happens. I'm going to print it. Insert into names, values, a null value. What comes next? What comes next? What's the payload of this attack? What's the next thing that's going to execute? Drop the table. Now notice this guy, this comment here at the end is just there to keep it from erroring out when it hits that stuff at the end. So I have tricked the database into executing attack code in SQL. And so when I try to do this, and then I try to select, so I'm going to run through it, execute it, and notice what I get. I got a red line there, and the red line says there is no such object as the table names. It got deleted. It's gone. There's a lot of cartoons, you know. Hey, is your son's name Drop Table Students? The principal calling the home and asking the mother, is your son's name Drop Table Students? Okay, that's a joke. Now this is called SQL injection. In order to protect yourself from it, there are ways to protect yourself from it, and we're gonna go there, and we're gonna get around this piece. But we have to deal with this because this is our major threat to a database. I was teaching SQL at a college in Corpus Christi, and I was teaching SQL. I had an SQL class, and the college blocked all SQL from coming through the Bastion host into the college web. So if I wanted to Google something about an SQL, I would try to Google it, and the firewall would say, "Oh my goodness, that's SQL," and oops, I hope I didn't do something terrible there. Should be cannot while you are recording this meeting. I don't want to minimize Zoom. I just want to. Okay, what did I hit wrong there? Okay, I'll push it down. Well, I don't know what I did. Okay, SQL injection. I inject SQL. Now we're going to see a way that we can block this easily from hitting our program, but it's one of your major problems in SQL. Very difficult because I can't allow SQL to come in. So that means I have to check that string that I'm getting from the web page if I'm going to use it in straight SQL. I really don't like it. This is a little bit like, I don't know, somebody hands you a pill. Here, swallow this pill. And you're like, oh, gulp.
The video dropped from the meeting.
Video, I dropped the video.
Yeah, but audio is good, obviously.
Okay. Can't minimize. I'm not trying to minimize Zoom. I'm trying. Somebody's chatting. Yeah, video dropped. Okay, I see that. So you're not seeing any. Let's see. Share. Oh, okay. I dropped the share. That's what happened. Now it should be back.
Yep, you're good.
Yeah, I'm good. Okay. SQL injection. Let's see, it's time for a break. And I usually need to get a drink of water about now. I'm not going to go over tonight. I'm, at when we hit 7:50, I'm cutting it off. Okay. So I'm gonna pause the recording. Somebody remind me to, and resuming recording. Okay. By the way, I'm going to give you these files, and I'll get them up there and onto their respective web pages. I am following the module fairly carefully, but I worked on it a lot today while I'm here. Okay, up until now, we have been executing our SQL code as if it were a DOS batch file. Do you know what I'm talking about? A .bat file where you say, okay, execute this guy, and he just reads the commands, reads the command, executes it, reads the command, executes it, reads the command, executes it. Okay, so it's kind of an interpreter, and in fact, it's a very rudimentary interpreter. It just does them one at a time. SQL file is just a text file, and the system just reads that text file and executes it. Now, one thing that we don't have in SQL Server that I like having is the ability to say, okay, just execute this file without opening it in the editor. You can do that in Oracle and most databases. You cannot do it in SQL Server. That's okay. I don't really need it a whole lot, but it's handy sometimes not to have to open the thing to do it. So I can just say, okay, execute it. I miss it, I really do, but I don't have it, so I'm over it. What I would like, or what we're going to do now, is we're going to develop compiled programs. And this is where we make a step now away from just the script that runs. So we do this, select from where, and then we insert something into it, then we select from where, and so we can put these things together and they run just fine. In fact, if you look at that create AP script, I mean, that's 1,000 lines and it runs in about 3 seconds. So it's not slow, but it's slow compared to other things. We're going to create compiled programs now. When we create a compiled program, the program will be stored in the database. It is no longer text. It is now a binary image. So it is the equivalent of moving from a text file like a Python file or a MIDI file or something that you're just playing through down to a compiled C file. More Java's compiled, but it goes through a couple of steps. So we're getting that. Now we're getting an executable file. Okay, so what is our first executable file? Always. What do you call it? The first one you did in C. What is it? Hello World. Okay, so let's do Hello World. Oh no, not Hello World. Hello world. If you want to say PROC instead of procedure, that's okay. I do believe you have to have the as in here. I always say create or alter because I'm always everlastingly doing it again. Create or alter allows you to, it doesn't have to exist or not exist. I don't want to have to say, you know, if object ID is null, then drop procedure. I don't have to say that. I can say create or alter. Other languages will say create or replace. So here is where we're going to start seeing some variation in the languages. So create or replace in other instances. It's just about the same thing though. What is the procedure's name? Procedure or PROC if you like. Most of them will accept that. And the procedure's name is, well, hello world, as begin. I'm going to declare a variable. Just, I didn't have to. I could have done it with just one line. I could have just said print hello world, would have worked exactly the same. But I'm going to go ahead and declare a variable just to show I can have variables in here, local variables that exist only inside of my program. Set hello is equal to hello world and print it. And when I execute this, it's a create, so it must be bracketed by go. It has to be in its own brackets. So there's a bracket, there's a bracket. When I execute this guy, I get that it completed successfully. Well, what completed successfully? I don't see hello world. What completed successfully was I created the program. I just compiled the program. Now I have the program. I can lose this text now. This text isn't anywhere in there. I can throw that away and nobody can read it except I know what it does. When I execute it, I can say execute, or I can just say exec, works the same, execute or exec, either one. Execute, and I get my, there's my hello world. Had I turned no count on, I would not have seen that completion time and all that jazz. I could have suppressed that stuff. And I was just seeing the hello world. Questions? I just created my first compiled program. What's the next thing we do? Always. If I can create a program that says hello world, I can create a program that says goodbye world. I'll create a program that says, hello, Dr. Smith, how may I make your life easier? And I can make my computer say all kinds of cute things. What else do I want to do now? I want to make my programs be more interactive. So what I'm going to do is now I want to talk about a program that takes a parameter. In other words, it takes input on its command line. If I can't do that, I can't do much with procedures. So a procedure has to be able to take input from me. So I give it, so this is hello world 2, and it has a parameter. The parameters that I declare in the body of the procedure are known as formal parameters. They're called formal parameters in every language. They're called formal parameters in Java, in C, in Ada, in Python. So it really doesn't exist until I give it a value and call it. So right now it's just a placeholder, but it's a variable there. And I don't know why I said a varchar 12. I don't know whether you use an as in between there or not, or whether you can. Lots of these, as we get into this, you will see variations in the syntax. Find one that works for you and use it. Right? I don't know whether as varchar as, lots of as is there. It's not a particularly pretty syntax. Let's see if it works. Execute less, it worked. I don't particularly like that one. I think I would just say my formal parameter is varchar 12. as, and then I'm going to say print hello, and then I'm going to append my formal parameter to it. So if I say hello world to Stephen, it will say hello Stephen. Sarah, hello Sarah. Right? I have to be able to do that. Now, I have to declare an actual parameter. Actual parameters are the ones that I give it to work with. So formal parameters are defined in the procedure. Actual parameters are what I say, okay, now do it and use this data, these data. And that's the way they're always going to call them that. A formal parameter is defined in the procedure. Actual parameter is what comes in. It'll never change. My actual parameter is Mars. I don't know why I'm saying Mars. I want to say hello Mars, I guess. And then I execute hello world 2, and I pass it my actual parameter. You will see it sometimes. It will be in parentheses. Sometimes it is not. I don't know whether it will accept parentheses or not. I know it doesn't like my parentheses, so I won't put them. No, I hate red lines. But you'll find them in parentheses very frequently, but if they're not, they're not. That's the way it goes. So when I say execute so declare, now notice that I don't have to execute the creation again. That's a execute. That's there. That exists. No matter where I go, I can, and if I can connect to this, I can execute this program. The other good thing, the thing that really makes this guy work now, I can give this program to someone else without giving it to them. I can say, okay, I'm going to give Juana the ability to execute my program, and then she can execute the program and she can say hello world or hello Mars or hello Jupiter, whatever, and she can execute it, but she can't change the program. She can only do what the program was designed to do, and therein lies the beauty, because I give you the ability to do something, to act on my data. I can put anything inside of these procedures that you know how to do. I can put any SQL. I can create table. We don't generally create tables. I can create a table. I can insert into a table, right, from this guy. I don't have to worry about it doing SQL injection because it's coming into a compiled program. It's not being passed in as a string and then executed as an SQL statement. It's being executed as an executable program. So I've got that layer of safety in there that you can't mess with this code because it's locked. I don't see anybody talking to me from on. Okay, questions out there in internet land? Let me give them a chance to talk for a second. Anybody want to say anything from my online pajaritos? That's my favorite word, pajarito. Do you know what a pajarito is? What? Ah, somebody's tweeting at me. Okay, what have I got here? Thank you for asking. What is it? Oh, pajarito, birdie. Good. Okay. I think it's a pretty word. Where's Paloma? Is she here?
May I ask you a question?
Of course. Ask a question.
Okay, when you create an executable program,
Okay.
and for that situation that happened, you lose the written one. Do you have a way to get from the executable and create the written one?
Okay. The answer to I've got my source code, and so what Juana is asking is if I go from my source code, which is this. Let me push this down. So this is the source that created it. And the question is, can I go backwards? And the answer is no. So something, don't lose it. If you once you create it, now it wouldn't be too hard to figure out how to do it, but and most of the time these programs are not real complicated. Some of them can be, but for the most part they're fairly simple logic that I need to stop you from doing things like SQL injection. So writing a procedure like that, now if you gave my formal parameter something really weird that was an SQL command, all it would say would be, you know, I would print, hello, drop table students, but it wouldn't do it. It would treat it just as a string. So it would never execute that string. This isn't dynamic SQL. And that's the beauty of this, is that it puts that layer of security. So we're starting to see the first of our layers of security. So this is going to be probably the most important one. Well, our first layer of security is our table constraints. So we said, you know, check that name is not null. Primary key, and we said the primary key, and then we say the foreign key. So those are table constraints. They stop bad data from getting into our tables. This will be our second layer, because I will not let you touch my tables. Not you, I mean, I like you just fine, but I don't want the grubby little world putting their fingers into my tables, right? Not, I mean, it's nothing personal, but I don't want anybody getting that close to my tables. So what I'm going to do is I'm going to create procedures like this. And the procedures will, you're going to give me something, you're going to say, I want to insert a record into the vendor's table. So I give you a procedure that inserts the record. And the procedure takes, I don't know how many parameters, how many values do I have to have there to insert. So I give you this guy and you say, okay, insert, here's the vendor ID, the vendor name, the this and that and the other, and my program checks them all. And it checks to make sure that that primary key isn't already there. If it is already there, it doesn't error out. It just sends you back an error code, because these procedures very seldom ever talk, right? This is unusual. So we're not going to write code that has cute output. Very unusual to, I'll only make it talk when I'm interested in seeing, you know, what's it doing. The output of a procedure is typically just a value that it returns to you. Okay, well, gee, now I can say hello. Now I can say hello, and I can make it change what it says, hello Mars or hello Jupiter, or say other things. Can I make it change its parameters? In other words, that Mars, what if I changed it? Well, it wouldn't change the actual parameter. Can I pass it a parameter and have it change that parameter in the file? And Juana says, should. Chris, what do you think? What do they call that? Pass by value. Pass by value, you can't change it. And pass by reference, you can change it. And it changes it in the main program. So in other words, I pass it something. It's a little bit like, here, I want you to average some numbers for me. So I give you my grade book. But I'm not going to give you my grade book. I'm going to give you a copy of my grade book, and you can average the numbers and then whisper them in my ear or something, tell me what they are. Or the other thing I could do is I could give you access to the actual grade book and let you average them up, but you can change them and pass that back to me. I don't know whether that's a good idea or not, okay? And they are dangerous, because what happens, you know, you can change the data that are in the main program. Well, it's not as big of a deal usually in database, because what I'm interested in protecting is the data, are the data in the database. Well, let's look at what I can do. I do ask you to do one of these. Let's see, 716, I think we can get it. Okay. Okay. Here is a this is a classic program. It's getting a little obsolete. I used to use this all the time. I kind of like it because it, back in the old days, back when I was, I had to walk to school 2 miles through the snow every day. Telephones had 24 letters on them. There was no Q and there was no Z. Each number, each of 8 numbers, 2 through 9, had 3 letters. And they went A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, R, S, T, U, V, W, X, Y. No Q, no Z. It was nice because there were 24 letters. You know why they changed that, don't you? How do you spell pizza without a Z? Would you? Well, anyway, it went the way of the text. So now if you look at your cell phone, Q is it has 4, and then Z's been stuck in there with 4. But back in the old days. This is pretty straightforward. Basically, I'm going to input a character. So this is the piece of this I want you to look at. Don't get bogged down in all the if logic. Okay. The digit is the output parameter. Do you see it? When I declare the formal parameter, I use the word output. Some languages you can put input right here. You can call this input. I guess it's not going to let me do that, but some will do that. Okay. I say one of them is an out because if I'm going to change it, I have to say so. If I change the first parameter, nothing happens. If I change the second one, it's changed in the main program. Pretty straightforward. It's just one big if statement. If you look through this logic, you'll find it finds the correct letter on the keyboard using 3 comparisons. It's very good if logic. So it checks, is it less than M? If it's less than M, it's got to be down here. Then it says, is it less than G? Well, then it's got to be the bottom half. Is it less than D? Then it's got to be a 2. And so on. And I just go through that. And at the end, okay. And so it changes that parameter. Now, when I call it, I declare a variable char1 output. My output is also a char, but I can pass you back a digit as a char. Okay, let's make it be an A. I make it anything. And then I execute telephone. I pass it, the first parameter I pass it is inval. The second parameter I pass it is outval, and I have to say output because I'm reinforcing the idea that it's going to get clobbered. Not all languages let you do that. C programmers, do we have any C programmers in here? C? Si, senor. And say, you don't say that. You just pass it, and it just clobbers it. Doesn't ask you. C is not a friendly language for the beginner. Neither is this, but yes, ma'am.
So telephone is the module that you have in front.
Telephone is this module that I'm, so this is creating the procedure. Telephone, so I created, here it is, go, I execute, and it says, now it just created, so now I have this program. So now I'm going to execute this program. So I declare a couple of variables to pass. Execute it here on line 90. And line 91 prints the value. That's going to be A, and whatever A is on the telephone keypad, and it tells me it's a 2. Oh, I knew that. Sounds like a lot of trouble just to write a text.
If you are gonna use it many times in public.
Well, I guess you could loop it and make it send junk texts to people, huh? Scroll up a little bit. Yes, I will. In fact, I'll give you the code. I don't want to get bogged down in this if logic. Okay, it works. Basically, it starts off here and it just goes in and splits it in the middle, and then it splits that in the middle, and then it splits it one more time. And so 3 comparisons, and I found it. I had to do 3 up here. First, I had to decide it was a good character, because if I give it something, I get a question mark. Oh, one more thing is that when I pass the parameters, when I execute it, notice that the first actual parameter goes to the first formal parameter. The second actual parameter goes to the second formal parameter. And that is the way it usually works in programming. That is the way it usually works. So it works that way, but you have another choice in this language. You have another choice. We also will accept passing parameters by name. I usually use pass by position because that is what I learned. If you are a Java programmer, you know pass by position. If you're a C programmer, you pass by position. There's no other way. But in this language, I have another option. Okay, let's check R. Now I'm going to execute telephone, but notice I'm reversing the parameters. If I'm going to reverse the parameters, what's going to happen? Wow, it's really going to mess it up. But I can tell it by the name. So I say digit gets outval, at digit gets outval, output, and ch gets inval. So I either have to know their position or I have to know their name. I can do it either way. You get to choose. Questions? Okay, just about to wrap up here. Okay, anybody's eyes rolling back in their head yet? Likely to. I tell you, this class is not going. I never said this is going to be an easy class. Okay, what? The coding is not difficult. What's difficult is the details. Now let's look at this last one here. This one is called vowel count. My procedure is called vowel count. Now there's an easier way to do this. I'm going to use a cursor here, and my junior level database teacher would be coming after me with a baseball bat if she saw this program. But this is a terrible program. Terrible. Okay. But it demonstrates some things. Vowel count. Okay, look at this. There's the name of it. Vowel CNT. It has a character. The first parameter is a character. Its name is CH. I use that a lot. The second one is an integer. Its name, CNT. It is an output parameter. What happens? Begin. If the character is in the set A, E, I, O, or U, those are vowels, then we count it. Add 1 to the second parameter. Pretty easy. Is that really that difficult of a programming task? Not much. End, go. Okay. By the way, I don't have to highlight the go. If I just highlight it, then it'll execute it. Okay, let's take a look at how we got to do now. Okay, now it gets a little, drop the table, create the table, put all the letters of the alphabet in the table. How many vowels are in the alphabet? 5. Okay, I'm gonna put them all in there just for fun. All in order. I didn't create a primary key, but hey, what the heck. Oh, look. There's a couple of variables, my vowel and my count. Those are just plain old variables. Oh no, a cursor. Select V from vowels. In other words, this is going to iterate through the whole table, all of them. Open him. Do my bash file. Fetch him. Execute him. Now, what did I do first? Oh, did you notice up here? Maybe you didn't. Let me get to him. Here it is right here. What did I do there? I declared my count. Yeah, my count. And what is it? Integer. And then what else is on that line? You said it. Zeroed it. Important little point there. Zeroed it. It started at 0. So the first time it goes into the procedure, it's 0. Well, the A is the first vowel. A is, so it hits A. What happens? It just got incremented. It counted it. It added 1 to the count. So each time in there, it checks, execute it. What happens when it executes? It checks it to see if it's a vowel, and then it increments that second parameter. I pass by position. If you wish to pass by name, that's your business. All right? I'm not going to exercise artistic control of your programming. Right? If you take my 1309 class, you know, and you got to write left outer join or right, you wouldn't write right inner join, would you? But inner join or left outer join, you can't just write join. Then here you can write join. And here you can drop the as. This is a terrible way to do it. I thought I had a I had something in there. It said, wouldn't it have been easier? Okay. Let me try one more quickie. I think what I did, I know what I did. I put this into another file, is what I did. And this is the same logic. I just pulled it out. And then I said, wouldn't it have been easier just to have done that if you wanted to know how many vowels were in that table? Wouldn't that have done it? Yes, it would have done it. Okay. I mean, but I do want to demonstrate the cursor. And okay, what am I demonstrating? I'm demonstrating using the cursor, and I'm demonstrating writing a procedure that takes both input parameters and output parameters, and it counts something using its parameters. I don't want you to be able to execute that. I'm only going to give you the right to execute that vowel count procedure. I'll give you that right, but I'm not even going to let you see my tables. You're not going to know what tables I have. You can't see them. You only know that I give you this procedure that lets you count vowels. And so you can execute this procedure as many times as you want to, but I'm not going to let you see the table. Well, I guess I'd have to, because I'd have to write the cursor on it for this. But we're going to use this, we're going to leverage this to build security. And the whole idea is that I can put the, I can put my insert and updates and deletes, bury them down in a procedure. And then I compile the procedure and I grant the right to execute these just to a select few of people, or maybe to the whole world. Maybe the whole world needs to use my code, or I grant it to the user that is the web server. So the web server gets knocked over. The web server now has suddenly become an infected attacker. All the web server can do is execute the code it can't get to the tables. It's pushed back out of the tables. So I built this firewall, and that's going to be a lot of what we're doing. We're going to build our layers of security like an onion around a fairly simple application. And as we build these layers of protection, it's going to get more and more complicated. The exercise I give you is fairly simple. By the way, that rock, paper, scissors game thing, that's the application we're going to do. We're going to build a rock, paper, scissors server. We're going to pretend that this is something that we have to protect because it's money. Rock, paper, scissors is another classic game. I have written that in a networking class where we built a rock, paper, scissors server. And it was thousands and thousands of lines, and 4 or 5 of us worked on it, and we had encryption and everything else on it. And just something that's silly and simple like that, you know, rock beats scissors, scissors beat paper, and so on. And so RPS. And you think that's fairly simple, but we're gonna push the users back out of it, where the user has a little bitty keyhole that they can act through and play the game, but they don't get to see the tables. We get to see the tables, they don't. Questions? Okay, I'm gonna wrap it there. Everybody says, it's about time. I tend to go fairly quickly because I want to be able to slow down and invite questions and comments. And that's what you can do now. Ask questions and make snide comments. Questions from my online peanut gallery. I'm watching the chat. Okay, I'm going to get these. Is that somebody talking from, or did that come from the, oh, okay. Did you get yours installed?
No, I don't
Okay.
have a space.
Just a moment, and let me. I'm going to pause the recording. I see you on the chat. Well, didn't mean to do that.